All right, so let's start with our first question. And it says use the substitution u is equal to tan x for n is not equal to -1. All right, so we have to prove that this integral here is equal to 1 over n plus 1 using this substitution. So first things first, let's just substitute something for dx over here. Fine. So for that, what we need to do is first write the substitution, then du by dx should equal to secant squared x, because that's a derivative of tan. Now let's just make dx the subject of formula, which will make du over secant squared x. And one substitution that we are aware of is secant squared x is basically equal to 1 plus tan squared x. So let's just write that as well. And the reason that I'm writing this is because that we are well aware our integral consists of tan, and perhaps using this conversion will help us instead of using secant squared x, right? So yeah, that's pretty much about it. Now let's determine the limits, which is 0 to pi by 4. So for limits, what we simply need to do is u is equal to tan of lower limit, which is 0. That's 0. U is equal to tan of pi by 4, which is equal to 1. So these are our new limits. So let's just rewrite our integral as 0 to 1. And instead of tan, we will substitute u, because that's essentially our substitution, right? U power n plus 2 plus u power n. Now instead of dx, we will substitute this. So let's just write this as du over 1 plus. Now instead of tan squared x, we will write u squared, obviously. So let's just write this. Fine. So this is our new integral in terms of u. It still looks a bit tricky, right? But there's a catch to this. Now the catch is, first, the reason that it looks tricky is because of n. You usually don't encounter such an integral. But there's one thing that we know, and that's indices, which we learned in IGCSE or O level. And we can perhaps split this and take something as common, right? Which is exactly what we're going to do. U power n multiplied by u squared plus u power n divided by 1 plus u squared. Now, does this make some sort of sense? Now, anyone here who's actually thinking will catch on the fact that we can perhaps take u power n as common, which is exactly what we're going to do. U power n, take that as common, u squared plus 1 divided by 1 plus u squared. Now, we obviously know that our numerator is exactly the same as denominator, which means we can just cancel this out simply, right? So integral of u power n times 1 times du is our final integral, and let's just solve this using simple power rule, which is u power n plus 1 divided by n plus 1, and substitute the limits, which was 0 and 1. Fine. Now, one thing to keep in mind is because we're solving it for du, we will substitute these limits inside of u, not inside of n. That's a common mistake. And let's just try to avoid that, shall we? So 1 power n plus 1 divided by n plus 1 minus 0 is our final answer. And we know 1 power anything is just 1. So 1 over n plus 1 will be our final answer. And therefore, we have proved the first part to be true. Fine. So that's just 4 marks for you right there. And now let's just move on and do more parts. So one thing's out of the way. Let's just move this down. Now we need to find the exact value for this integral right here. Now notice the fact that this looks like a somewhat decent difficulty of integral, right? And yet it's only for 3 marks, which just suggests the fact that we will perhaps use this over here, this entire result, and it will aid us into solving this integral. But the first things first, this is in terms of secant squared and secant power 4x. Meanwhile, this is in terms of tan. So the obvious thing to do here is to convert all of this integral into tan. So it shouldn't be too hard, given that we know the substitution 1 plus tan squared x is equal to secant squared x, right? So let's just substitute this. First things first, secant power 4x is just secant squared x multiplied by secant squared x minus secant squared x, right? So we can write this as 1 plus tan squared x into 1 plus tan squared x minus 1 plus tan squared x. Now let's just solve this quickly. Simplify this, I mean. So this should be 1 plus 2 tan squared x plus tan power 4x. and this should be -1 and minus tan squared x. So 1 gets cancelled out. 2 tan squared x minus tan squared x is in fact tan squared x. So let's just write this down as this: 2 power 4, tan power 4x plus tan power 2x. Now this is somewhat decent, and it's similar to the form which is given to us over here: tan power n plus 2 plus tan power n. Now how can I make this tan power, how can I make this tan power n plus 2 as tan power 4x? I would obviously need to substitute n is equal to 2 over here, right? Because 4 minus 2 is 2. And if I substitute n is equal to 2 here, this would literally become what we have over here, which is tan power 4x plus tan squared x. Now, the reason why I determined that is because the question clearly explicitly mentions that if you determine n, you can literally find out the answer for this integral without having any method in mind. So we determined that over here, if we substitute n is equal to 2, we can obtain this similar integral, right? So over here, our answer should just be 1 over n plus 1. And what was n? Over here, for this situation, n is equal to 2, because substituting n is equal to 2 would give us tan power 4x over here. So let's just write n is equal to 2 over here, and this will give us our final answer as 1/3. That's pretty much it, and that's 3 marks obtained. Now, let's move on to the final part, which is a little bit more trickier than this. And it clearly states all of this, but the tricky part here is that we have coefficients now, 5. Now, one could say, okay, we can just take 5 as common, write this as tan power 7x plus tan power 5x, and yeah, then we can just solve this using n is equal to 5 and stuff, But my question to you is, if you start doing that, what about this and this? How will you solve that? Well, the method that I'm thinking of is, in fact, better than this, I believe. And for that, what you need to do is you need to split this and this. Now, how will you split it? One obvious fact is that 5 tan power 7x could be written as tan power 7x plus 4 tan power 7x, right? And 5 tan power 5x could be written as tan power 5x plus 4 tan power 5x, right? Now, the reason I want 1 over here is because I can use this with tan power 9x and use this with tan power 3x. And these two, I can just take 4 as common and use this as well. I need to make use of this over here because it's only a 3 mark, and there's no way I can determine all of this given that the exam time limit is not that high, right? So we will obviously you do the wiser choice and use the smarter way, which is to convert this into this form. Now, if I convert it like this, this will make my life a lot more easier. Let me elaborate how. So let's just convert it using the method I told you. So tan power 9x will be written as tan power 9x, and 5 tan power x can be written as we discussed right now, tan power 7x, my bad, plus 4 tan power 7x, right? So this can be written as this right here. Now, how about 5 tan power 5x? This can be written as tan power 5x plus 4 tan power 5x. And this can be just written like we normally do, tan power 3x. Now, this will make my life a lot more easier if I just rearrange this properly. So I'll do that. I'll just write this as the way it was, these two, I mean. Tan power 7x, all right? So these are arranged. Now, I can take these 4's together because I can take them as common. 4 into tan power 7x plus tan power 5x. And finally, I can take tan power 5x this with this. Tan power 5x plus tan power 3x. The reason I'm grouping it like this is because it clearly says n plus 2 and n. So this over here can be n, and this can be n plus 2 because 3 plus 2 is equal to 5, 5 plus 2 is equal to 7, 7 plus 2 is equal to 9. Does that make sense? And the reason I've grouped 4 together is because in that way we can just take the 4 as a common and just solve this individually and multiply our final result with 4. Does that make sense? So now I will compute all of these individually. All right. So I can just add an integral sign over here and an integral sign over here because according to integration, that is allowed. Once you're adding some things together, you can clearly just group them like this. Fine. So now let's just solve this. Tan power 9x plus tan power 7x. Let's just solve this first. So how will we solve this first? We want tan power 9x over here. So n plus 2 should equal to 9, which means n is equal to 7, right? Because tan of 7 plus 2 is equal to 9, and this is tan power 7, which is exactly like this. So for this, n is equal to 7. Fine? And which means our final answer will be 1 over 7 plus 1. Does that make sense? So 1 over 7 plus 1 for this part of my integral, plus, now what do I do here? First things first, take 4 as common. And what about this? Tan power 7x plus tan power 5x. Okay, so n plus 2 should equal to 7, right? So n should equal to 5, obviously. So if I substitute 5 here, tan of 7x plus tan power 5x, which is exactly what we have over here. So we can just substitute tan n is equal to 5 over here, which is 1 over 5 plus 1. Therefore, this should give us our answer as 1 over 5 plus 1, plus now this last integral, in which we need tan power 5x plus tan power 3x. So over here, we can simply just write this as, we need n plus 2 to be equal to 5, right? Because that's the power of our original equation. So n is equal to 3. Fine. So we can substitute this here and there, and therefore our final answer will be 1 over 3 plus 1, which is equal to 1 over 4, but I'll just write it as it is, plus 1 over 3 plus 1. Now, if I add all of these, what I will get is essentially my final answer. And let me just calculate that real quick using a calculator. 1 plus 5 plus 1 plus 1 over 4. And our final answer is in fact 25 over 24. And that's how you approach this question. So the main gist of this question was, in fact, that you had to prove this. And once you have proved this, you have to use this over here and over here. That's pretty much about it. Here you had to convert this in terms of tan x. And here you had to split this in this form. Now, what I did was I split this in terms of 1 and 4 and 1 and 4. And that just made my life a lot more easier. So that's pretty much how you attempt this question.